13C number 4. It says here, many women take oral contraceptives to prevent pregnancy. Under ideal conditions, 1% of women taking the pill become pregnant within 1 year. In typical use, however, 5% become pregnant. A study of the effectiveness of oral contraceptives interviews a random sample of 500 women who are taking the pill. Based on the information about typical use, what is the probability that at least 25 of these women become pregnant in the next year? Is the normal approximation permissible? So the main part of this question is this right here. This is what we're asked is if the normal approximation is permissible. If you remember in the lecture, this is the condition for the normal approximation. So it says here, if n is large and p is not too close to 0 or 1, the binomial distribution can be approximated by a normal distribution. Practically, the normal approximation can be used when both n times p is greater than or equal to 10 and n times 1 minus p is greater or equal to 10. So let's go back to the question. We're looking at the typical use. So typical use, our p is 5%. So 5%, I know it's small, but that's not really that close to 0 or 1. I mean, something that's really close to 0 or 1, you know, it's just like a few decimals close to it. So like 0.999999 would be close to 1, or 0.00001 would be close to 1. So 5% is okay. We can use this p. So if we use this p, our n that we're using is 500. Okay, so let's take our calculator. The first condition is n times p greater than or equal to 10. So 500 times 0.05, 25. So does that satisfy this first part? Yes, it does. It's greater than 25 is greater or equal to 10. So the next what you call condition is n times 1 minus p. So let's take that out. So 500 times 1 minus, again, it's 0.05. And let's see if that's greater or equal to 10 as well. And that's 475. So that's also greater or equal to 10. So in our question, it says here it's between A, B, and C, right? And D and E are not right because it does fulfill the normal approximation requirements. So A says yes because we may reasonably assume that the population is normal. So that's not true. That doesn't have any supporting evidence. It says in B yes because the sample is large, and that's not true. This isn't the way we actually prove that the normal approximation is permissible. So C says yes because NP and N times 1 minus 2 are not smaller than 10. So that's it. That's our answer. We solved that NP is greater or equal to 10 and N times 1 minus P is greater or equal to 10. So for number 4, it's C. So really useful to memorize this condition. It might show up on the test, so get familiar with it.